projector. And Melissa is here. Okay. Before we actually get started, let me just go over a couple of things. Number one, the math team had an organizational meeting yesterday. I was in class, so I couldn't go to it. It was on the Birmingham campus. And one of my students from the last class that I thought was going to it, he was going to it, but he didn't know exactly. He got lost going there. He's not used to the Birmingham campus. And he wound up at Winona High School, and he was so close, but not there. So anyway, he missed the meeting, so I haven't found out what went on there. But as far as I know, we'll start meeting Monday and Wednesday. We would have met yesterday, except the one student I knew who was going to participate. She said, we got a meeting at 3, so she had to go over to the Birmingham campus. So we'll start meeting Mondays and Wednesdays, sometime after 3:15, and stop sometime before 4:45. We don't have to go that long, but however long y'all want to do it. So if you would like to do it, even if you don't want to go to the competition, I think you'll find it really helpful for upper level math courses, because we'll be doing all sorts of fun things in that. The other announcement is, I normally give saying one way, now it's the other. Normally on Fridays I have office hours 7:45 to 11:45. But this Friday they actually get extended to 12:30 because they've called a meeting on the Birmingham campus at 12:30. So I'll be there 11:45 until 12:30. Then after 12:30 I'll be in the meeting and not be available. So I'm actually going to be available 45 minutes longer than I normally would be, or between 30 and 45, because I have to go over to the meeting. So I'll leave a little before 12:30. All right, any questions on anything we've done so far? All right, last time, I know we went over this, but this was the last slide we did completely, okay? And there are those identities again. Those are the definitions, I would say, of the trigonometric functions. They're identical to what we've had before. Even if you think unit circle, everywhere you see an R here, put a 1 in there, and you got the same thing, okay? Then when we're doing acute angles, we have exactly the same thing. The only difference is we've extended to obtuse angles, which means that the x and the y's can become negative. If you're over here, your x's are negative, y's are positive. Down here, they're both negative. Over here, the x's are positive, the y's are negative. So the only difference here is they can be any point, positive, negative, or whatever for x and y. But remember, your R is always positive, never negative, never 0. It can't be 0 because you're dividing by R, okay? So, because R, which is the square root of x squared plus y squared, cannot be 0, because the number 0, 0 doesn't occur anywhere there. So both x and y cannot be 0 at the same time. Follows that the sine and the cosine functions are defined for all real numbers. There's no place sine and cosine is not defined. For all real numbers there. However, when x is equal to 0, then both the tangent and the secant are not defined. When x is equal to 0 here or here, tangent and secant are not defined. Therefore, the tangent and secant cannot have x equals 0. Where x equals 0, you're on the y-axis. So at pi halves and 3/2 pi or any multiples of those, you can't have 2 pi multiples of those. They can't be defined. And similarly, y can't be 0. If y is 0, the cotangent and cosecant x are not defined. In other words, cotangent x and cosecant x are defined only for y is not 0. Where is y 0? That's anywhere on the x-axis. So that means it's 0 to pi or any multiple of pi. Okay? Positive or negative multiple of pi. So x equals 0, tangent and secant, theta are undefined, and when, for instance, the tangent of 90 degrees, or pi halves, undefined. You can never find that. Okay. Similarly, when y is equal to 0, cotangent, cosecant are undefined, and that would be 0 degrees, 180 degrees, pi, 2 pi, whatever. So let's do example 1. Let negative 3, 4 be a point on the terminal side of angle theta. Not a bad idea to draw a graph. Always helps to see what you're doing. So let's do a graph, okay? And we'll tick off a few points here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Way more than what we need. Okay? All right. Where is negative 3, 4? Second quadrant. Something about like there, I think. Okay? There's the point, negative 3, 4. Okay, let that point be on the terminal side of theta. So here's the terminal side of theta. So this is your angle theta. Okay? Find the cosine, the sine, the cosine, and the tangent of that angle theta. How do we do that? This is negative 3 here, and that's positive 4 there. How do we do that? What else do we need to know to get sine or cosine? What are sine or cosine? I'm getting smacked in the face with a whole lot of silence here. Okay. What's the definition of sine? From that. This what? Okay. Opposite over hypotenuse, that's certainly true. Okay. So now you have to talk about what you mean by the opposite of that angle theta. Well, the opposite is your y value. I know that doesn't look like it's connected with theta, but indeed it is. So this is going to be your y, and what is your hypotenuse? We used to call it hypotenuse, which would be fine. Well, let me go and write it as you said. Opposite over hypotenuse, which in this case is y over what? R, exactly. It was only a couple slides ago. There it is. Sine is y over r. Okay. So what is your y? Four. And what's your r? Oh no, they didn't give it. We can't do it, can we? Yes, we can. How? Here is, oh, this is Justin. And this is Mike, right, sorry. Now, remind me before the end of class, because we don't have everybody here, there is one other pretty major announcement. I forgot to do it to my morning class, but it didn't matter with them. And this is it Jeremy? Huh? Taiwan? Yeah. And y'all left and came back. Anyone else come in since I called roll? Okay. Remind me when more people get here, I do need to make a pretty major announcement. Like I said, I forgot to do it in my first class, but it really didn't matter for them. It does matter only, it does matter for this class, but not for most of you. In fact, not for any of you, but for some others in the class. And I want to say it when they get here. Well, let me say it now so you'll know, and then you can remind me. I'm supposed to, I may have even told you this last time. The vice president sent an email that we're supposed to read, but I can't print it because my cartridge is out. I ordered it back in August, and it still hasn't come in. So I can't print the thing, so I'll just tell you basically what it is. As of tomorrow, anyone who has not completed payment for a class will be removed from the class. Now, all of you have completed your payment, as far as I know. At least when I looked last Thursday or Friday, you had. But you may know of someone who hasn't. I don't know, maybe waiting for the financial aid, waiting for a scholarship, waiting for your company to pay, waiting for the whatever that delayed payment plan or whatever. If there's any reason you are not paid or your friend may not be paid, please tell them to complete payment by tomorrow, or get in touch with the financial the business office and let them know what your process is. That yes, you're going to pay, you've been coming to class, you're just waiting for this last piece of whatever, let them know so I think they can put a flag by your name and not remove you from the class. I don't know if they can. I know they've done it in the past. Whether they can do it now, I don't know. But please, if you know of anyone who hasn't paid, please let them know they need to do something by tomorrow. Get in touch with the financial service. It's actually the business office, cashier's window, before tomorrow or by tomorrow. Okay. Well, we were there talking about what R is, and we got distracted. What in the world is R? Oh, yes, there it is. R is the square root of x squared plus y squared. Okay? And square root of, in this case, what's your x? Negative 3 squared plus what's your y? 4 squared. And what's negative 3 squared? I'm sorry? 9. What's 4 squared? 16. What's 9 plus 16? And what's square root of 25? Do you need to do plus or minus there? No, because R is always positive. Never 0, never negative. So now can you finish what sign is? 4 over 5. Perfectly fine. Get out of there. Okay. How about cosine? What is it? A little louder. Negative 3 over 5. It's your x over r, which is negative 3 over 5. And what's your tangent? A little louder? Okay. You can write it as 4 over negative 3, which is the same as negative 4/3. Okay? I like to pull the minus sign out in front. Doesn't matter. You can put it anywhere you want to. It's negative 4/3. Okay? That you could have done without calculating r, because you already knew everything you needed. Y over x. Okay? Any question on that? All right. Let's clear my chicken scratch out of the way and see what they do. Referring to the figure, they drew it too, almost as pretty as mine. They identified what the R was. That is that hypotenuse, the line that goes, and here's Tyrell. From the origin to the point in question, negative 3, 4, that length is r, and we know that is the square root of x squared plus y squared. Okay? Plugging in the values, that's negative 3 squared plus 4 squared. Square root of that, that's square root of 25, which is, of course, 5. Always positive, never negative, never 0. R. X and y can be positive, negative, 0, whatever. But R cannot be. It's always positive. Okay? So now you just write it down. Sine of theta is y over r, which is 4/5. Cosine theta is x over r, which is negative 3/5. And tangent theta is y over x, which is negative 4/3. Got it. Any questions? Could you have given the others? Cotangent, secant, and cosecant? Say again? Sure you could. Just reciprocal of this. Negative 3/4 would be cotangent. Negative 5/3 would be secant. And 5/4 would be cosecant. Very good. All right, let me back up one. There is a checkpoint right after example 1. Good idea to do that as soon as you can after class. Okay? Now continue with the introduction. The signs, the SIGN signs of trigonometric functions in the 4 quadrants can be determined from the definitions of those functions. In other words, where the x's and y positive or negative. Because r is always positive. So all you have to worry about is where the x's and r's. Well, cosine is x over r. R is always positive. So whenever x is negative, cosine is negative. And where is x negative? And second and third. X. Second and third. Anywhere left of the y-axis, x is negative. So cosine is negative in the second and the fourth quadrant. The second and third quadrant. Okay? So cosine is positive whenever x is greater than 0, first and fourth, and negative when it's not first and fourth, second and third. R is always positive. Okay? So you can always determine that. Now, here's your how we express this. In the first quadrant, guess what? Everything's positive. X is positive, Y is positive, R is positive, because R is always positive. So therefore, every trig function is positive in the first quadrant. Sine, cosine, tangent, cotangent, secant, and cosecant. They're all positive in the first quadrant. It's anytime 0 is between, the theta's in between 0 and pi halves, or 0 and 90 degrees. But in the second quadrant, only the x is negative, the y is positive. So anything that depends on x, cosine and secant, and tangent and cotangent, because tangent and cotangent depend on x and y, but if y is positive, x negative, then cotangent and tangent will be negative here. Cosine and secant will be negative here, because they're reciprocal of each other. Okay? Meaning the only things that are positive here are sine, which depends on y, and r is always positive, and its reciprocal, which is cosecant. Down here, x is negative and y is negative, so sine's negative, cosine's negative. Of course, that would mean cosecant's negative and secant's negative. But tangent and cotangent, because they're both negative, that's y over x. Negative over negative is positive. So tangent and cotangent are positive down here. Everything else is negative. Over here, x positive and y is negative. So therefore, the things that depend on x alone, cosine and secant, are positive here. Everything else has a y in it, and either an r or x, but r is always positive and x is positive in the fourth quadrant. So all those things are negative in this quadrant. Sine, cosecant, tangent, and cotangent. All negative. So, I think I've given you this before. Think of this as all. All trig functions are positive in the first quadrant. Only the sine and its reciprocal, cosecant, is positive there. Only the tangent and its reciprocal, cotangent, are positive here, and only the cosine and its reciprocal, secant, are positive there. So one little acrostic that some people use is all students take calculus. That would be nice if they did, but they don't. And some people say all state technical college. I don't care what you say, but those are your, what is positive in the various quadrants. Everything in the first quadrant, only sine and its reciprocal in the second, only tangent and its reciprocal in the third, only cosine and its reciprocal in the fourth. Okay? Or you can think of the definitions, and where depends on x alone, sine and cosecant. Positive there. X and y both being negative, so tangent and cotangent are positive here, and everything else is negative. Depending on x along, that's your cosine and secant. Positive there, everything else is negative. Sorry about my throat. I went to the UAB game on Saturday and yelled too much. Sorry. Okay, Doc is here. And since you're here, you may not go back and listen to my announcement earlier on, so let me say it again for everybody to hear. The Vice President came out with a memorandum last week, and I was supposed to print it off and read it to you, but my printer's not working, so I couldn't do that. But basically what it says is all students who have not completed payment by tomorrow will be removed from classes. Okay, so if you or someone you know has not completed payment, they need to either complete payment, that'd be the best idea, or get in touch with the business office and let them know where you are in the process. Look, I'm just waiting for this, or waiting or whatever, and as soon as you get it, you're going to pay. They may not take you off that. I think they can maybe put a flag on your name and keep that from happening. So if you know of anyone who hasn't completed payment by tomorrow, please let them know their name's going to be removed from the roll. Okay. All right, we just finished the top of page 291, figure 428. So let's move on. Whoa, they skipped examples 2 and 3 at least. Okay, so let's do them here. Given that tangent of theta is equal to minus 5/4, and that cosine of theta is greater than 0. Find sine and secant. Can you do that? Where would you begin? Hint. You gotta know where you are. Where are you, Waldo? If tangent theta is negative and cosine theta is positive, where is it that tangent is negative? Anyone? Say again? 2 and 4, absolutely correct. So you know you're either in quadrant 2 or 4. Cosine theta is positive. Where are you then? 4 or 1. Well, guess what? For tangent to be negative and cosine positive, you got to be in 4. Because if you were in 2, cosine would be negative. Okay? So you got to be in quadrant 4. So that's the first thing. You're in quadrant 4. Okay? You're in quadrant 4. Okay? Now, since you know where you are, draw your picture. Okay? Tick out a few points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? Now, you're in quadrant 4. What is, and by the way, what is tangent, by the way? Help me out here. What's the definition of tangent? In our tangent is y over x. Okay? In tangent 4, quadrant 4, one of these, y or x, is negative. Which one is it? Really? No, y. Yeah, y is. Let's do it early. Okay? So therefore, it is negative 5 is your y, 1, 2, 3, 4, 5. So there's your y, and your x is positive 4. Okay? So there you are, Waldo. This is the angle theta we're talking about. Okay? We know that x is equal to 4, y is equal to negative 5. What else do we need to know to get sine? That's what we're looking for. Say again? The radius. And what is it? What is your r? The square root of, a little louder, x squared plus y squared. All right? And that will be the square root of 4 squared plus a negative 5 squared, which is square root of 4 squared. Say again? 16 plus 25, and that would be the square root of 41. Nice round number, okay? That's your r. So your r is the square root of 41. Okay, now can you tell me what sine is? What is the definition of sine theta? Y over r. We know what y is, right? We know what y is, right? What is it? Negative 5 over root 41. Now, I'm perfectly happy with that as an answer, but if you or the back of the book don't like square roots in the denominator, you could write that as negative 5 root 41 over 41. That's just a little extra writing, and it happens to be they leave it the way we first had it. Okay? Now, they also are asking for secant theta. Now, there's two ways to go about this one. You tell me, what is secant theta? Okay, r over x. You went straight to the definition. R over x. And I think we know that is an x, not a 4. We know what r is, right? Square root of 41. And what's our x? 4. Done. Whoa! Is secant positive in the fourth quadrant? Yes, it's reciprocal of cosine. All students take calculus. So cosine is positive there, therefore secant is 2. So yeah, that's making sense. The other thing that makes sense about it, sines are always between -1 and 1, and 5 is certainly less than the square root of 41, because 5 is square root of 25, right? Square root of 25 is less than the square root of 41, so this is a number between -1 and 1. However, secant and cosecant are always either greater than 1 or less than -1, or equal to. Okay? Well, square root of 41 is greater than square root of 16, so this is always greater than 1. Got it. So that makes me feel warm and fuzzy inside. And when they changed it to decimal numbers, they got the first one to be about negative 0.7809, good for side, and secant to be a 1.6008, which is good for secant as well. All right, any questions on that? You could have given me all 5 of them. They gave you tangent. What would cotangent have been? Yes, negative 4/5. Just reciprocate that. What would cosecant have been? Yep, r over y. Cosecant. So you just reciprocate that. Square root of 41 over negative square root of 41 over 5. And what would cosine have been? You know it was positive, so it's in the fourth quadrant. It would have been 4 over root 41. You got it. Good deal. So you could have done all 5 of them that they didn't give you. Now, Let me erase this. Any questions before I erase it? Okay. Now, there was a checkpoint after example 2. Please do those as soon as you can. Says here, evaluate the cosine and tangent functions at the 4 quadrant angles. So we're looking for cosine of theta and tangent of theta at the 4 quadrant angles. 0, pi halves, pi, and 3 halves pi. Okay? What is cosine theta? It's what? X over r. Very good. Now, do we know our xy pairs at theta equals 0? Now, we don't know what r is, so if it doesn't matter what r is, let's just let it be 1. Go back to our unit circle. What is the ordered pair for theta equals 0? 1, 0. For theta equal 2 pi halves? What's your xy pair there? Say again, at pi halves. 0, 1. At pi? Negative 1, 0. And at 3 halves pi? 0, negative 1. Okay, so what's your r? Okay, a little louder. Okay, the square root of x squared plus y squared, right? Now pick one of those points, I don't care which one, any one of them. 1, 0. So there it'd be the square root of 1 squared plus 0 squared, right? Which is 1. Okay. So what is cosine of theta? 4. Okay. Cosine of 0. Yak. Say theta. Say 0 and write theta. Okay. Cosine of 0. What is it? One. Cosine of pi halves. 0. Okay. Cosine of pi, negative 1, and cosine of 3 halves pi. So what? 0. Very good. What is tangent of 0? What is tangent of anything? It's what? What's the definition for tangent theta? A little louder. Y over x. I'm hard of hearing. So what is it here? 0. Tangent of pi halves. Undefined. Okay. Cosine of pi. That's what? Okay. Didn't you say it was y over x? There's your ordered pair. What's that? Oh, wait. I said cosine. I'm sorry. Meant to say tangent. I don't know where my brain was. You answered correctly. I wrote it wrong. Tangent of pi. 0, you're right. Okay, I can't hear. Sorry. And tangent of 3 halves pi. What's that? Tangent is y over x. -1 over undefined. You can never divide by 0. Okay. So, see that? The next one is evaluate the side and the cotangent. This is the checkpoint. Cotangent functions at the quadrant angle 3 pi over 2. So you can do that on your own. All right. Any questions on the quadrant angles? All right. Now we're going to talk about another concept that, believe it or not, we've really already used, but we didn't name it. So we're going to name it now. These are called reference angles. The values of the trigonometric functions greater than 90 degrees, okay, greater than pi halves. In other words, anything in the second, third, or fourth quadrants, okay, or any less than 0, meaning in the fourth, third, second, going around that way. Negative angles can be determined from the values at corresponding acute angles. Here is a key word, acute angles, called reference angles. So number 1, reference angles are always acute angles, always, okay? Now, what can you tell me about the trig functions of all the acute angles? They're always positive, okay? So your trig functions of your reference angles are always going to be positive numbers. But you're then going to go back and change the sign depending on what quadrant you're in and what trig vector you're talking about. So here's the definition of a reference angle. Let theta be an angle in standard position. That means going from positive x-axis around this way. So theta is that angle in standard position. Its reference angle is the acute angle theta prime, okay, that's what this book calls it, theta prime, formed by the terminal side of theta and the horizontal axis, okay? So let me draw a few angles here. Of course, anything in the first quadrant, this angle theta, standard form, it's its own reference angle because that is an acute angle. That's equal to theta prime. Theta prime is the same as theta, okay? You don't even need to mess with the reference angle in the first quadrant because you already got it. Okay. And this is, remind me your name? Doc. Okay. And what's that? Yeah, I'm sorry. And you're Tadarius. I was thinking that was Tadarius. I marked in the wrong place. Okay. And again, I want to say this because every time somebody else has come in, I want to make sure you and everyone you know gets to hear about it. The vice president sent a memorandum sometime last week. I can't remember what day it was. I was supposed to print it out and read it, but my printer's not working because my toner went out. And I ordered it back in August, and it still hasn't gotten here. So I couldn't print it to read to you. Basically, it says this. If you have not completed payment by tomorrow, you're going to be removed from the roll. So what I'm asking you to do, anyone you know here at the college, if you think or suspect or know that they haven't completed payment, please let them know. They will be removed from the roll tomorrow, probably at the end of business. I don't remember exactly what it said, but I believe that's usually what they do. Now, sometimes there's an exception to that. If you're in the process and you're just waiting for some other piece of paperwork or something like that to happen, or your boss or your company or your scholarship or something else, or some check to come in or something like that, if that's all you're waiting for, but you're guaranteed that you're going to make the payment, go to the business office today, no later than tomorrow, and let them know what your situation is. I think, I'm not sure on this, but I think they can put a flag on your account and make sure you don't get removed from the roll. I don't know that for a fact, but I know they've done it at least one time in the past. I remember they said they did put some flags out there to keep people from being removed. So please let all your classmates and friends know they've got to make their payments by tomorrow. Okay, so back to first quadrant. The angle is its own reference angle. That's an acute angle already. It's made with the horizontal axis. If you're any angle in the second quadrant, here is the angle theta. I probably should erase the others so you don't get confused. So let's do away with that one. Here is the angle theta now. There's your angle theta. Where is its reference angle? Yeah, that's it right there. There is a reference angle, theta prime. It's made from the terminal side, the angle theta prime, from the terminal side of theta and the horizontal axis. So whichever way you want to do it, it's an acute angle, so it's all the trig functions are positive. That's the reference angle for that. And you just nailed it because you said that theta prime here is equal to 180 degrees minus whatever your theta was. There's the other way to look at it. Or, if you think in radians, pi minus theta. Okay, if theta was in radians. So that's exactly how you get the reference angle there. Okay? Now, let's move to the third quadrant. Okay? For any angle in the third quadrant, there's your angle theta. Okay? Where is your reference angle? It's that part of it right there. There's your reference angle theta prime. It's from the horizontal to the terminal side. That's it right there. It's acute. Okay? Now, how do we find it? Yes, you start with the angle theta and subtract that 180 or pi from it. So in the third quadrant, your reference angle theta prime is equal to theta minus 180 degrees, or theta minus pi. That's exactly how you get it. That's the reference angle. The pictures to me are worth it because you see exactly what you're talking about. That's what it is. Okay? Now let's move to the fourth quadrant. Okay? Okay. For any angle in the fourth quadrant, here is the angle theta in the fourth quadrant. Where is its reference angle? That's it right there. There's your theta prime. From the terminal side to the closest horizontal axis. That's your theta prime. What's the relationship there between theta prime and theta? Anyone see it? Say again? Yeah, exactly. So theta plus theta prime obviously is 360 degrees or 2 pi. Okay? Well, then what would theta prime be? Theta prime would be 360 minus theta or 2 pi minus theta. Okay? Yeah. You just subtract this from both sides, and that's what you get.
So you always go with the closest horizontal.
What's that?
The closest horizontal.
Closest horizontal. That's exactly what it is. The terminal side to the closest horizontal. And it's probably better not even to put an arrow on it, because you don't want you to think, oh, it's going counterclockwise or clockwise to its next. No, don't even mess with it. Just put the arc there, and that's your theta prime. That acute angle. Okay? So two things about acute angles. They're always acute. Reference angles are always acute. Therefore, the trig functions are always positive. However, you use your all-state technical college or all-state calculus or chemistry or whatever you want them to take with a C. You use that to determine the sign that you're, SIGN sign. Okay. So that's why we use our reference angles. That's how we define them. So here is what we just discussed for quadrant 2. The reference angle, theta prime, is from the terminal side of theta to the horizontal axis. Whichever way you go, doesn't matter. That acute angle there. And therefore, the reference angle, you can think of that theta prime plus theta is equal to pi or 180 degrees. Then subtract theta from both sides, and that's what you get. Theta prime is equal to pi minus theta or 180 degrees minus theta. If you have theta in degrees. Okay, if you're down in the third quadrant, here's your reference angle. Okay, that angle right there, the acute angle between the horizontal axis and the terminal side. Always acute. All the trig functions are positive in that angle. However, the sign of them will depend on which quadrant you're in. How do you get this? That 180 plus theta prime equals theta. So theta prime is equal to theta minus pi over minus 180 degrees. Fourth quadrant, just like we said, there's the reference angle, theta prime. Theta plus theta prime equals 360 or 2 pi. So subtract theta from both sides and you get theta prime equals 2 pi minus theta or 360 minus theta if you're in degrees. Okay. Sorry, my voice is weakening. Actually, it wasn't too bad yesterday, but after teaching 4 classes, that was about 6 hours of teaching. And then I was in a meeting last night and my voice was almost completely gone. And it hasn't gotten much better this morning. Okay, so now the question is, you find the reference angle. Given theta equal 300 degrees, what do you reckon its reference angle theta prime is? And you can either go by the formulas or you can go by pictures. I think pictures are easier, but you decide. Do a picture. Okay, I like the idea. Okay, theta is equal to 300 degrees. Well, where are we, Waldo? We're not in the first quadrant because that would only go up to 90. We're not in the second quadrant because that would only go to 180. We're not even in the third quadrant because that would go to 370. So we must be in the fourth quadrant, about 30 degrees beyond 270. Okay? So what's its reference angle? Say again? Okay, except it's got to be acute. Yeah, it's the acute angle. 270 is to here. Yes, this would be 60 degrees. Okay? Why? Because 60 plus 300 is 360. Yeah. Makes sense, doesn't it? All right. This next one, what? Okay, so this theta prime is equal to 60 degrees because add that to 300 and you get 360. All right, let's do this one. So what I'm going to do is erase this, and all that. Okay. Now we got to figure out where in the world are we, Waldo? Where is 2.3? What does that mean? 2.3. Okay. 2.3 without a degree sign means you must be talking about radians. Ugh. Well, let's think what we know about radians. What would all the way around here be? How many radians? No, all the way around would be 2 pi, but pi. How much is pi? 3.14. So you're less than pi. What would this one up here be? Pi halves. Now pi is just a little bit more than 3, right? Divided by 2 would be a little bit more than 1.5, 1.5. So this is greater than that. So we must be somewhere in the second quadrant. Where, I'm not sure, but we're in the second quadrant. You're between something that's about 1.5 and something that's about 3.1. You're in between those two, so you're in the second quadrant. So how do you get the reference angle? Say again? Yes. How do you know it's pi? How do you know this is in radians? Is that what you're saying? Anytime you just have a number with no degree symbol, you've got to be in radians. So pi has no degree symbol, that's in radians. If you ever had pi degrees, that's bizarre, but you could. You're in degree mode, but it's 3.14 degrees. That's a really small angle. So you know you're in radians because you have no degree symbol. And that's what we're saying. This would be pi, which is 3.14. This would be pi halves, which is a little bit greater than 1.5. So 2.3 has to be between 1.5 and 3. So somewhere in the second quadrant. What is your reference angle there from that terminal side to the closest horizontal? So this is your theta prime. And what is the value of that theta prime? Second. Yes, exactly. Pi minus 2.3. Okay? Why? Because theta plus theta prime, theta plus theta prime is equal to pi. You know that. That picture tells you that. But your theta was 2.3 plus theta prime is equal to pi. So solve for theta prime, subtract 2.3 from both sides. Theta prime is equal to pi minus 2.3. Either look at it and see that, use the algebra to see that, however you do. All right. Now let's do C, which is yes in Spanish. Okay? All right. Theta is equal to negative 135 degrees. Where are we, Waldo? Second? Fourth quadrant, we say. Fourth quadrant, minus means you're going clockwise. So this would be 0 to 90. So you're past that. Are you as much as 180? No. So you're somewhere in between. So we're in the third quadrant. Somewhere down there. Okay? So this is your angle theta. Theta is equal to negative 135 degrees. Somewhere there in the third quadrant. What's your reference angle? It's the from that terminal side to the closest horizontal axis. That's right there. There's your theta prime. Okay? Now, how do we figure out what theta prime is?
Angle 135, subtract 180.
Okay. You say start with 135 and what?
Subtract 180.
Subtract it from 180. That looks like it'll do it to me. What does that be? 45 degrees. Because each of those is degrees. So theta prime is equal to 45 degrees. That's how I would do it. Now, I think they'll probably make it a lot more convoluted than that. But you know that, just forget about the minus sign. You've gone 135 degrees here. You want to go 180 degrees total. This one here is the difference between 180 and 135. That makes sense. Now let's see. We'll see how they do it. Okay? The reference angle is never negative. It's always acute and always positive. Okay? Always. So all the trig functions are positive of that reference angle. But then you go back and to give them the sign of the quadrant they're in. So that's the procedure we're going to do. So I'm going to erase all these and we're going to, y'all need it yet? Leave it, yeah, okay. Let's see how they do it. Well, they use just the formulas. That theta prime is in the fourth quadrant, theta prime is 360 minus 300. Yeah, if you like to memorize a bunch of formulas, go for it. I like to draw the pictures and see what it is, but that's exactly what you get, and that's 60 degrees. 60 degrees in degrees. Okay, fine. Okay. The next one, oh, this now shows that. Do the picture first, then do the calculation. It makes it so much easier. Okay? This one, they just say, hey, it's in between these two. So therefore, it's that. They don't, well, they will draw the picture, but they go straight from the formula first and then approximate it, okay? And then show the picture. I would do the picture first and then you see. 2.3 is somewhere in the second quadrant. Subtract that from pi and you get your answer. And that's it. No formula is required, really. Now this one, like I said, they can figure out a way to make it complicated. They first changed the minus 135 to 225 by adding 360 to it. Once they've done that, they say, oh, now we're in quadrant 3, which we had already figured out long before then. Okay? So the reference angle is, since you're in quadrant 3, by memorizing the formulas, it's theta minus 180 is your reference angle. It would be so much easier to do it the way you did. You know, just say, hey, it's got to complete 180 degrees. What does it take? Sure enough, that's still 45 degrees. Okay? And here's the picture. And why in the world they went to that much effort to first calculate how many degrees. If this is how you see it best, do it, by all means. But it seemed like to me this is 135 degrees. At reference angle, it's got to be the difference in that and 180. So just do it, okay? But they made it to the coterminal angle and then use the formula that told you the angle minus 180 is the reference angle and that gives you 45. It works either way, okay? Your way was much easier. All right, any questions? Now, we're moving to find trigonometric functions of any real number, no matter what quadrant the angle happens to be in. So here's how we do it. To see how the reference angle is used to evaluate the trigonometric function, consider the point xy on the terminal side of theta. Draw it in the second quadrant, it could have been in the third or the fourth. Here's your point on the terminal side. Now we know already x is negative, y is positive, okay? and R is the hypotenuse, it's always positive, always positive, always positive, never zero, never negative. Okay, now, they then take that reference angle, theta prime, and use the positive values, opposite, adjacent, hypotenuse. Only the positive, because you count this as an acute angle, so everything you're going to count is positive. Even though this is actually negative, but count it as positive with that reference angle, and then do the calculation. If you're looking for sine, opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, cotangent adjacent over opposite, secant hypotenuse over adjacent, and cosecant hypotenuse over opposite. Do the trig function just for that acute angle, keeping it positive. Whatever angle you're dealing with, give me an angle. There's six, trig function. There's six of them, give me one of them. Sine. What is the SIGN sign of the SIN sign in this quadrant? Positive. So you do your calculation, opposite over hypotenuse, and then give it a positive sign. Well, guess what? If you just left the y positive over this positive, you know it's going to be that. So, yeah, it's easier to deal with the acute angle, so deal with the acute angle, but give the sign according to this thing, okay? Rather than doing absolute values, undoing and then redoing, do it, but give it the sign that you know it's got to be, okay? And that's what they're saying to do. By definition, you know that sine theta, and you probably should have said sine theta prime here, because you're usually dealing with the reference angle, is y over r, and tangent is y over x. Was that a problem, or was that just a... They just picked sine and tangent. They weren't asking for it. Okay, they just picked those two. So for the right triangle with acute angle theta prime, the sides of length x and y, okay, you have sine of theta prime is your opposite over hypotenuse, which is your y over r. Okay. So frankly, to me, it's so much easier just do sine of theta, use the value of y, not absolute value, the sine value of y over r, you get it. It gives it to you right there. Just knowing that you use the same references here for the angle theta as you do for theta prime. Okay? Same thing here. This is absolute y over. If both of these were in the second quadrant, this is going to be positive, that is going to be negative, because your x was negative, your y was positive. So you can go through absolute values and then doing all this stuff, but in the long run, use your signs to show you what it's going to be. Okay. Now, so it follows that sine theta and sine theta prime, in other words, the sine of the angle theta, when that's in any angle greater than pi halves or 90 degrees, and the sine of theta prime, which is always an acute angle, are always equal except possibly in their sign, SIGN sign. The same is true for tangent and tangent theta prime, cosine and cosine theta prime. The value's the same, it's just what the SIGN sign is. Okay? So in all cases, the quadrant in which the theta is located, where you found out where you are, that determines the SIGN sign of the trig function. So evaluate a trig function of any angle, find the value of the trig function of the angle theta, first determine the function value associated with the reference angle theta prime, and then depending on the quadrant in which theta lies, affix the appropriate sign of the function value. Okay? Now, that's perfectly correct. It's a great way to go. To me, determine the reference angle theta using the x's and y's and r's just like they exist, knowing that theta prime is always an acute angle, but go on and calculate it. But then, whatever the original signs, SIGN, of your x and y are, let that determine what the sign of your angle theta is. It's doing the same thing, it's just not quite as much work. So, the quadrant will certainly tell you, or if you just use the signs of the coordinates, they will tell you. So, either way you understand it best. You can greatly extend the scope of exact trigonometric values. For instance, if you know the value functions for 30 degrees, then you also know the value functions for the thing whose reference angle is 30, which would be 150 degrees. Or 210 degrees, 30 past 180. Or 30 short, 30 short of 360, that would be 330. So you know all those. If you know the function values at 30 degrees, you know the function values of 30, 150, 210, and 330. You know. You just give the sign that's appropriate, SIGN sign appropriate for them, and it's the same numerical value, always, of the reference angle. So they say for convenience, this table shows the exact values of the sine, tangent, cosine, and tangent functions of the special angles, your 30, 45, 60, 0, 90, and your quadrant angles. Okay? And give it in degrees or radians. The sine of 0 degrees or 0 radian is 0. Sine of 30 degrees or pi 6 radians is 1/2. 45 is the square root of 2 over 2. 60 or pi thirds is the square root of 3 over 2. And 90 would be square root of 4 over 2, which is 1. This is square root of 0 over 2. Okay. Now for 180, again, over here, the y value is 0, so that the sine is 0. The x value is minus 1, so for cosine that would be minus 1. The tangent y over x would be 0 over minus 1, which is 0. I didn't do tangent, 90 degrees, I should have done that. But you know these, we've done them all before. Okay? These, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Cosine goes the other way, square root of 0 over 2, 1 over 2, 3 over 2, 3 over 2, 4 over 2. For tangent is just use these. 1 over that, this over that, this over that. But tangent is undefined at 90 and 270 because your x value is 0. So let's do a few. You tell me what the cosine of 4/3 pi is. Good idea to do. Draw you a picture. Where are you, Waldo? 1/3 pi is like that. 2/3 pi is like that. 3/3 pi is 1 pi, and 4/3 pi would be like that. So where are you? The third quadrant. Cosine has what? SIGN sign in the third quadrant. Negative. Okay. What's your reference angle there? Second? 180. The reference angle is this acute angle here. Theta prime. Okay? Now, this was given in radians. radians is 180 degrees? Pi. It's exactly pi. So you're how far beyond pi with 4/3 pi? Pi is how many thirds? Pi is how many thirds pi? 1 pi is how many thirds? 1 is how many thirds? 3/3. Okay? So 1 pi would be 3/3 pi. This is 4/3 pi. How much further have you gone? From 3/3 pi to 4/3 pi. 1/3 pi. So that's the angle. Theta prime is 1/3 pi, or pi over 3. What is the cosine of pi over 3? That's what?
I was about to say the cosine of 4 pi over 3. I know the cosine of 4 pi.
What is it?
Is it -1/2?
Yes, exactly. Okay. So if you can get it, if you know it already, it's -1/2. Okay. But using the reference angle, this is pi thirds, 60 degrees, and the cosine of pi thirds is 1/2. But you're in the third quadrant, and cosine is negative in the third quadrant. Okay, let's do tangent of -210. So what I'm going to do is erase all this. Now, again, I like to figure out where we are. -2/10 means we start going in the clockwise direction from the positive horizontal axis. How far would you go from there to here? How many angles is that? How many degrees is that? That would be -90. This would be -180. And how much further do you need to go to get to 210? .30 degrees. And that, by the way, is your reference angle. Theta prime is equal to 30 degrees. Okay? Now, you're doing the tangent. What quadrant did you wind up in? And what is the tangent in the second quadrant? What SIGN sign is it? Negative. So this is going to be a negative number. And what's the tangent of 30 degrees? I don't know that one as well as I do the others, but what I do know is sine over cosine. Sine of 30 degrees is 1/2. Cosine is square root of 3 over 2. So the 2's go out, and it's -1/√3. Or negative square root of 3 over 3. Okay? You want to hold up? I know we just ran out of time. Sorry about that. We'll do the C one next time, if I can find it. Okay. Last time we stopped at the B one. Last time I taught this. So we'll do the C next time. Any questions on that? -√3 over 3, -1/2. We'll start with the third one next time. Okay, homework exercises here in this 4.4. We almost finished, folks. But your homework exercises are either 9 or 11 or both. Any of the odds 13 to 17. Either 19 or 21 or both. Any of the odds 23 to 31. Any of the odds either 33 or 35 or both. Any of the odds 37 to 43. Any of the odds 45 to 51. Any of the odds 53 to 67. I think we can stop there. We'll pick up the rest of those next time. Okay, before you go, now you don't have to if you don't want to, but I did get your first test run off. Since we almost finished 4.4, you can at least get started on these if you want to. They won't be due until a week from probably Thursday when we finish this section, so this just gives you an extra couple days to work on. Is that okay? Okay, I don't think you need any graph paper. So if you'll take on and pass 2 down. Take 1, pass 2 down. Did I give y'all enough? Okay, you got it. Take 1, pass 1. More people who are up there will get this. Sorry about that. I'm real sorry. Okay? All right.
Is this all I need to put on the paper?
Now, if you can't find enough or not, or don't like what it's telling you, all right, good deal.